Hi, my name is Frank Kowalski,
I'm Stokes.
and this is our final presentation for our senior technical project, electronic fuel injection conversion. So a little background to kind of give you an idea of what this project was. We had a stakeholder, his name is Jerry. He has a 1953 Chevy 3100 pickup with a 401 Buick Nailhead engine in it. Now, 401 Nailhead was only made from 1959 to 1966. And being that it is a kind of rare, kind of uncommon engine, there's not many parts available for it at the time, and we'll later get into the difficulty of finding some of the parts and the parts availability, trying to use what we had at our disposal.
So challenge we had early on in the project, we had to get a lot of parts from different places, so we had to wait for a lot of those parts to come in. Some of them shipped from online, some of them came from different people. The base flanges on the intake itself need to be CNC milled, so that took about a week or so of time so that they could be machined properly. Same with some of the other parts, we had to wait for it to get welded. Frank and I's TIG welding skills weren't completely up to par. We wanted to make sure the process was done right, so we sent it out to get welded, and so that we would be welded properly. The other thing was, being we're still in our senior semester of school, so we still have school. Frank's on the Woodsman's team. I'm a member of the Baja City team, so there's a lot of extracurricular things and schoolwork as well. So another challenge was trying to schedule our time properly so that we still have plenty of time to get the project done and make sure that we could get what we needed done on time.
So moving on, parts availability was a big issue for us at one point. So as I said, parts from this were hard to come by. A lot of them had to be found in random places or even fabricated by us. And all the parts came from many different areas, such as the injectors were taken off an older Lincoln in a scrapyard in Buffalo, as they were big enough to provide the exact pound-hour amount of fuel that we needed for this engine. Another piece, the throttle bodies and the fast EFI system that would be used to control and tune the engine itself were purchased from a fellow student of ours, Alex Kroll. The metal that we used to build the intake was all 6061 aluminum. That was purchased from State Line Supply Company in Bradford, Pennsylvania. Multiple other parts, the distributor, the injector bungs, they were all purchased online. I believe all on eBay actually from various different parties. And obtaining these all took a decent amount of time. Some, as for driving to Pennsylvania to get steel, driving to Buffalo to get the injectors, waiting on parts to come in from eBay. And all this time was time that we either couldn't work on the project as we possibly needed these parts to take measurements off of to design a new feature, or we just needed them to be added on until we moved on so that we could move on with the project itself.
All right. So soon the parts started coming in, and we started to really make some progress on the project. We spent a good chunk of our time right at the beginning in Professor Hellig's machine tool class and lab. He was a huge help to us. He lent his knowledge and his very expensive tools to his very expensive machines to help us get some key parts of our project done, like welding the holes, machining the holes for the injector bungs and milling down the faces on the side of the runners. A lot of the parts we did make ourselves, but a few we had to send out. Like I said before, the base flanges on the intake itself. Those were CNC machined on a Haas 3-axis lathe mill by Paige Haley, a fellow MET student. She had previously taken the CAD/CAM major, so she was a very big help. And then another thing we had to send the thing out was, as I said before, was to get welded. We ended up taking it over to Bosse's in Cornell, and Haggerty and his assistant Spencer did a very good job at welding up the intake for us. We also spent a good amount of time early on in the project with Professor Smith over at the Alfred State Motorsports. He was a big help. He let us use the metal roller, and he was just a very had a lot of guides of wisdom, and really helped us move the project along.
So we have here a couple pictures of our progress on the project itself. Over here we have, as Spencer was just talking about, we worked in the machine shop quite a lot. This is a picture of us setting up the intake itself on the mill. And we used the mill to drill the holes in each of the runners for the injector bonds. And this was a difficult process. It took a lot of Mr. Helwig's knowledge and a lot of his machining tools to get it done correctly. Here, as Spencer just said as well, are the base flanges for the project that Paige Haley CNC'd herself. So obviously that took a little time in her having to create the code for the program that would make these flanges out of the 1-inch aluminum stock that we have. And we chose to have them CNC'd. They have to be quite accurate and exact to fit on the engine. And here on the side, we have a slightly older picture of our intake. And as you see right here on the ends are some of the larger runners, the plenums that we were originally going to use, which we'll get into soon, how we downsize those. And also these top angled pieces here were taken out of the project to save space and save welding time. And they really just weren't needed as we moved on the project. We realized that we could do without them. So we took them out and simply placed the runners a little lower.
All right, so as Frank just said, we had a little bit of an issue with the size of our plenums. The original plenums, as you saw in the previous picture, those were rolled on a metal roller on a piece of flat 66 aluminum plate. Those were about 6 inches in diameter after they were made. And after talking to our stakeholder and just talking among ourselves, we kind of decided that having that much space, extra space in the plenum itself would create opportunities for stagnant air. And we figured that would be detrimental to engine performance. It might cause some issues with air-fuel ratios, maybe cause it to run too lean, run too rich. So we decided to downsize the plenums themselves to 3-inch tube, which is a 65 thou wall thickness. And we figured that would be an adequate size to be able to still allow air into the engine with no restriction, but also make sure that it was being distributed quickly and accurately, so that way it would not stagnate and always be in motion. The other thing we also did was, as Frank talked about, we took the top elbows out of the runners to shorten the height, bring in the width a little bit, and it also allowed for a much straighter shot into the combustion chamber of the engine, while still providing adequate airflow and plenty of power.
And so along with this came a few calculations that we have, beginning with the throttle body calculations, which we thought about last semester as well when we began this project, and we just went over them again. And basically it's just a measure of the cubic feet per minute of air. So it takes into account maximum RPM, volumetric efficiency, the displacement of the engine, and a few constants. And this number came out to 694 CFM. And with 2 throttle bodies, this would be met perfectly with that. There'd be no issues in the amount of air intake. But the original plenum volume itself calculated out to be 452 cubic inches around there. So with that, that's quite a lot of air just sitting in the plenum itself. And this kind of prolongs the time that it's in there, and it wouldn't exactly be forcing the engine as quickly as we'd like it to, so that it's possible that there would be overfueling, not enough air coming into the engine. There'd be more fuel than air, so that the engine wouldn't run properly. So we came with a new plenum volume, which is approximately 113 cubic inches, and this is obviously significantly lower than the original 6-inch design. This is a new 3-inch tube that we used. So with this smaller volume, the air is much more quickly forced down into the runners as more air comes in. Obviously, it has to replace the air that's already in there. This will force it into the engine, and it will run much more properly, as it's not sitting there kind of just circling around in the plenum that long.
So my foreseen difficulties we had throughout the process of the project, like I said, we ended up taking the plenum over to Professor Haggerty, or Mr. Haggerty over at BOCES. But before that, we had some trouble finding someone who had adequate TIG welding skills to be able to weld the plenum. We did some looking around. It ended up being that Haggerty and his partner, his co-professor, would be the best fit for the job, and they did an amazing job at it. Some of the machining, some of the pieces took more time than we expected. With the base flanges that Paige did, we had to make a few little design changes, and he had to do some tooling changes as well, because just to streamline the process of the milling, and to make sure that it was successfully milled properly. The injection bugs, when they were first originally welded in, they were welded in actually at the wrong angle, so they had to be cut out and re-welded in at the proper 45. And then the other issue we had was lining up the throttle body plates and making sure that the throttle body plates not only sat on the same plane, but so a linkage could be running between them, so they'd be running simultaneously.
And so with these difficulties, we had to come up with multiple solutions to these problems. As Spencer said, with trying to find somebody to TIG weld these together, we ended up going to the greater southern tier BOCES in Harnell, where Professor Haggerty and his co-professor Spencer Hildebrand were able to fully weld the intake. They were very good with the TIG welder, and they were very knowledgeable about the project itself. As for the machining, there's nothing we could really do to rush that process along. It's obviously a careful process, and they had to take their time in doing it. So we simply had to wait, and this obviously took time and postponed other parts of the project that we had going on. The injector bungs, as they were originally welded incorrectly, which is partial faults of ourselves and just simple lack of communication, which is obviously a good learning experience for us in the future. These had to be taken. I took them myself and I cut them out with basically an angle grinder. I had to take and cut out all 8 of the injector bungs to place them back in at the correct angle so that they could be welded in and the fuel rail could fit in properly. And lastly, with the 2 throttle bodies, they have to turn simultaneously. So a connecting link had to be made between the 2, and they had to wait until they were all, the whole intake was welded together so that they could be placed on there and the exact measurement of the 2 could be taken so that they could be welded in properly and at the same angle.
All right, so here we have some of the final design pictures. The one over here on your left is the finished plenum with the throttle bodies off. So in here you can clearly see the throttle body plates with their mounting holes. the hole in the middle of in them that lines up exactly with the entrance through the throttle body into the plenums. You can also clearly see the cross pipe in the back. The cross pipe helps us make sure that both plenums have an equalized pressure across them, so that one doesn't have more air in it at the same than the other. They will equalize out as air flows through them. And then you can also clearly see the row of injector bungs on this one side welded in at 45-degree angle to make sure that the injectors and the fluid rails will clear. And then this one over here, and then also we have sitting next to our presentation screen is the plenum with the throttle bodies on it. And as you can see that they were lined up properly, and being that they're identical throttle bodies, so they both have a TPS throttle position sensor that mounts on the outside. So to allow the linkage to be running between them, we were actually able to take the throttle position sensor off the other throttle body, and we're going to have a mounted rod that will be mounted to that piece and then connected to the other piece to allow the plenums to actuate at the same time.
Yeah, this is just a render of our SolidWorks drawing here. As you can see, as Spencer just said, it's got the throttle body plates, the crossover tube. We even added in the injector bungs, the fuel injectors themselves, and the fuel rail is right there, which is being purchased and produced by a man down in Pennsylvania. He creates these themselves, so it's very precise, and it takes some time to make this. So right now, it's not actually been produced yet.
All right, so we've made it this far, but we're not done yet. We still have a lot more work to get done. The truck itself needs to be completed. It's currently sitting with the customer suspension, front suspension, engine and transmission in it. I think it might still need a drive shaft, but it still needs to have fuel tank on it. And then the fuel lines are in. The fuel EFI system itself is very plug and play. It's very easy to use, and that's a lot of credit to Fast and all of their engineering. So all we're going to be able to do is what we have left to do is get the plenum on there, plug in the few sensors that we're going to need, run fuel to it, and then hopefully we'll have a running engine. And not too long after that, probably after finals week, we'll have a running truck. And we'll probably be coming back after our finals week is over to just ensure that the truck is running properly and allow for any tuning that might need to be done.
And so just to finish up, a few acknowledgments to all the people that helped make this project possible for us and helped us along the way. Jerry Perry, he's the stakeholder, the owner of this truck that we've done this entire project for. We worked with him along the way, purchasing the parts, designing the project, how he'd like it. Professor Hellwig gave us a lot of his knowledge and the use of his machine shop, which without many of these parts wouldn't have been made. His machines, and with his guidance, we were able to produce many of these parts ourselves. And we learned a lot in the process of how designing and the fabrication of the project go hand in hand. Professor Smith over at Motorsports allowed us his knowledge as well and use of his equipment, such as the rollers which we use on the original plenums to roll the sheet metal into the tubing. Paige Haley and Clark Strang are students here. Paige Haley is in the CAD/CAM, also mechanical engineering program. As Spencer said before, she CNC'd the base flanges. Clark Strang, he helped mill out one of the plates that mated the runners to the plenum itself. As we weren't very knowledgeable about these systems, we had to go outside and get outside help for these pieces. Sean Haggerty and Spencer Hildebrandt, the professors over at BOCES, their help with welding the project together. Without them, this intake wouldn't be together right now, most likely, as we couldn't find anyone else with the capability or the time to put this together for us. Professor Tomasi, our advisor throughout this project, and also the one who originally taught us how to use SolidWorks, the main program we used to design this entire thing. So obviously without his teaching and guidance, we wouldn't have been able to design this as well as we did in the first place. Alex Kroll for obtaining many of the parts, helping us along the way, as he had great knowledge of fuel injection systems himself, and just assistance throughout in getting parts and helping us with the project. And then last, and obviously there's more, but Ian Cook provided many of the original parts that we began this project with. And there's more people, a lot of people, too many to name at this point, but we've received plenty of help from other people when we encounter difficulties, and they helped us either get past them or taught us how to move on through this. And this is our works cited page. Thank you.
Thank you very much.